Welcome to Kishore's Neet Padasala. In this video lecture, we will see about the concept of impulse. Impulse is denoted by the letter J and it is a vector quantity. J vector is equal to F into T. So F into T, we know that force is equal to del dP by dt, which is the Newton's second law. So force into time is nothing but momentum. So change in momentum. So impulse or change in momentum, both are same thing. Area under an FT graph, it gives the impulse. So this is indicated by an integral sign. Integral sign means it is nothing but the total thing. That is the area under an FT graph gives the impulse. So F into T is delta P. Delta P is initial momentum minus final momentum, that is M into V minus U. Now let us see this numerical. This is a common type of numerical. Impulse imparted on the ball by the ball. See, a ball is there of mass m. It is moving with velocity v and it is bouncing back with same velocity v with an angle theta from the ball. They are asking impulse imparted on the ball by the ball. Okay, let us resolve the component. Along the angle cos theta, v cos theta and v cos theta. Away from the angle which is sin theta, which is v sin theta, and since it is this direction, arrow I am putting in this direction, which is v sin theta. Okay, now this is along the positive axis, so plus I cap. This is along the negative axis, minus j cap. Now I am writing PF, sorry, PI, initial momentum I am writing. Initial momentum is along the xth component, mv sin theta into plus I cap plus mv cos theta into minus j cap. Since it is in the downward direction, it is negative y-axis, minus j cap. So which is mv sin theta I cap plus, sorry, minus mv cos theta into j cap minus sign. Final momentum, similarly I am writing along the x-axis, but it is pointing in this direction, so it is minus I cap, minus mv sin theta into I cap minus mv cos theta into j cap. Here also, since it is in the downward direction, here also it is minus j cap. What impulse is nothing but change in momentum, which is pf minus pi. If you subtract these two equations, pf minus pi, then the answer comes out to be minus 2mv sin theta into I cap, which is the impulse imparted or the change in the momentum. Okay, so this thing you must remember as a formula, and this is a common type of question. Now let us see second question. Impulse on the wall by the ball. So what is the impulse created by the ball on the wall, they are asking. See that because of the ball bouncing, does the wall get moved? Does the wall gets moved? No, the wall doesn't get moved. So there is no impulse created, which is simply I can say 0 Newton second. Okay, that is the impulse on the wall by the ball. Now let us see this question. A ball of mass 1 kg is dropped from height 20 meter. It bounces the ground and goes back to a height of 5 meter. See, a ball of mass 1 kg, it is dropped from a height of 20 meter. And again it goes back to a height of 5 meter. Okay. So let us see what is the change in the momentum, which is change in the momentum is pf minus pi. Final is m into vf minus m into vi. See here, since it is moving along the negative direction, I take it as a negative axis. Since it is moving the positive y direction after bouncing, I am taking this as a positive axis. Final is m into, mass is 1 kg, so I am just writing 1 into root of 2g into final height reached is 5 meter. So 5 meter plus I am putting, since it is moving along the positive axis, minus of. Okay, my mass is 1 kg, so 1 into vi is root of 2 into g into, it is dropped from 20 meter. and here I am putting negative direction since it is moving along the negative axis. So minus and minus, it gets plus, so plus. So answer comes out to be, take g is equal to 10, answer comes out to be 30 Newton into second. That is the change in the momentum or the impulse imparted. Okay, and this is the next thing. Previously we saw that if the angle is from the wall, then delta p is 2 mv sine theta. Suppose if the angle is like this, in this way, then the delta p is 2 mv cos theta. It is similar to the previous way we worked out. Just to remember as a formula. In exam it takes more time to do these things. You remember as formula. Okay, now this is the next numerical we have. Momentum is given, time is given, they are asking the force. So F is dp by dt. I am differentiating this equation. Differentiation of 2 is 0 plus 3 into 2 into t. So force is 60. At t is equal to 3 seconds, force is 6 into 3, that is 18 Newton. Okay, now let us see this question. A ball of mass m is moving towards a player with velocity u. So initial velocity is v. If the player stopped it, so final velocity is 0. What is the impulse they are asking? Impulse is f into t is equal to m into v minus u. So impulse is equal to m into v is 0 minus u is v. Initial velocity is v, so which is minus mv. So minus mv vector is the correct answer. I hope you like this lecture. If you like this lecture, please subscribe Kishore's Neet Padasala. Thank you.